Good day to all of you. And this is our first lesson in National Instrument Multisim 14.2. I believe in learning by doing. So let's start our lesson by opening the NI Multisim. NI Multisim 14.2. Let's wait for it to be active. Okay, it's beginning to be active. And it's active now. You can see here the workspace in Multisim. So there are so many icons, the instruments, lasers, place basic, diode, transistor, place analog. So if you for us to be proficient in Multisim, we need to memorize this icon. Unlike AutoCAD that has an command line, Multisim has no command line. So we need to really memorize ourselves in memorize or familiarize ourselves in these icons. So we can do that by using Multisim open, then it will be automatic. We can find those icons or for those instruments. So our first problem is from our reference book, the 11th edition of Electronic Devices and Circuit Theory. We have this circuit and it has a computation. The computation is shown here and the results. For the problem, for the series diode configuration, determine the voltage across the diode, the voltage across the resistor, and the current across the diode. So let's simulate this circuit using the Multisim. So let's go to our Multisim. Get the source. You can get the source by place, component. You can find here the source. So I think you need to copy the circuit like this. So the source is 8 volts. 8 volts DC. 8 volts DC. Let's enter that in the Multisim. Sources. Let's find the DC source, power source, DC power. So this is a battery. Let's click OK. So in our circuit, the value is 8 volts. So let's change that. Change this into 8 volts. Right click, let's double click that. Let's change that to 8 volts. Okay. Let's go back to our problem. We need a diode, silicon. So from this, place component, all families. Oh, change that into diodes. Take note that these are models of an actual diode. So let's try first the virtual diode. Okay. Then we need one resistor with 2.2 kilo ohms. You can use that technique or you can use this technique. Search for a resistor that has a value of 2.2 kilo ohm. 2.2 kilo ohm. Okay. Close this. Or now we need another component which is the ground. The circuit will not function without the ground symbol. It represents the negative side of the circuit, negative, or the ground. A circuit without ground will not work. So place component, sources, where's the ground? Ground is in the sources. Okay, let's put it here. Close. Then we will connect all this circuit. This is a series circuit. So connecting the circuit, you need to find the terminal. We need to uh, arrange this, rotate clockwise the terminal. Okay, we now have a circuit that looks like this. So, and the problem is to find the voltage across the diode, find the current flowing through the silicon diode, and find the voltage across the resistor. So to do that, to measure those values, we need to use a multimeter. So voltage across the diode, VD, you connect a voltmeter. So this is a voltmeter. Voltage across the diode, you need. Okay, let's continue. Let's continue. Set the multimeter into voltmeter. Voltmeter means it will measure voltage. Okay. Then another multimeter to find the voltage across the resistor. And another multimeter. Now, connect the terminal of the multimeter. So the problem should what is the voltage across this resistor? So we need to set it also as a voltmeter, DC. The supply is battery, so this is DC. Another parameter that needs to be measured is the voltage across the diode, current flowing through the diode. So we need a multimeter. If we are measuring current, it should be connected in series. Should be connected in series. The ammeter or current meter. So we need to set this as an ammeter. Now the circuit is complete. Let's see if our simulation will have an output similar to the computation shown in the book. So how to do that? We use this simulate. And now we have the value. For the multimeter, for the ammeter, the value is 3.32 milliampere. Let's see. 3.32 milliampere, so that is correct. For this diode, what is the voltage for this voltage across this diode? The answer is 0.686 millivolts. So converting it into voltage, that is 0.686 volts. So let's see it. 0.686 volts, almost the same or the same. If we round up, if you round this up, it's 0.7 volts. The voltage across this resistor or BR, let's find out. 7.3 volts. So 7.3 volts. So we got the correct answer. The computation and the simulation are the same. So that's how easy Multisim to use or utilize in simulating our circuit. The only problem that I have in this, if you want to stop the simulation, press this button. The only problem that I encountered in using this is familiarization with the icon. Familiarization with the icon. So, if you want to save your circuit, file, save as. Save it. Design 1, MS14. Let's look for a folder to save it. For sending to AUP, laboratory, save. File, new. Let's make a new, create. Okay. File, open. Let's open our file. So that's how to use Multisim. Very simple. It's very simple, but again, we need to be familiarized. Where are those components located? Very simple. Uh, it is like uh, putting the actual components. This is a battery in actual component. This is a power supply. This is a diode, a two-terminal device. This is the positive, negative, anode, and the cathode. And we all know the resistor. 2.2K. If it's actual, you need to find the resistor with this color code, 2.2 kilo ohm. It's color coded. It's been the tradition, but I believe now it is more easy if they can print the value. But they are not doing that because it has been a tradition. Just put 2.2K on the resistor's body or case. But I think I still believe that the color code is more fun. So that's it. That's how we use Multisim. Okay, that's our video lesson 1, video 2.